Okay, as the scientist said when he got to the pearly gates, for my first slide, please. So I want to tell you about the history of the universe. Just to point out that it has taken 13.8 billion years for you to appear, for the universe to produce you, and that each of us is the product of 3.8 billion years of 100% successful reproduction. All of our ancestors survived long enough to make our other ancestors, and so when you think about optimism, think about 100% success rate. It's been going on a long time. So stepping back a little while, 64 years ago, I was 6 years old, and I asked my father, where did we come from? And of course, he didn't know. So what I'm going to tell you, we did not know when I was a child. He did know that there were chromosomes and genes, and he told me that when I was 6 years old. So that got my attention, and I thought, that's really interesting. So that explains how I'm different from my friends and neighbors. Maybe why I have some interest in science. It's clearly not fair that we don't all get the same start. There's a social justice question there. But basically, we didn't know. Even the double helix had not yet been discovered that year. So that was a time when I was young and curious, and I started reading everything as soon as I could read about science. When I was 8, we went to the Museum of Natural History in New York and saw the dinosaur bones and the volcanoes and heard about the planetarium, heard the planetarium show, and I got to know more about this. So we got a little telescope to look at Mars, and you couldn't see a darn thing. It's too little. Sears Roebuck telescope that big isn't going to show you anything. But I read everything I could read, and so I got started in science. So when I was 8 years old, also my parents liked to read out loud to me and my sister, and they read stories from the biographies of Galileo and Darwin. So when Al and Alda told you about storytelling, well, that one had a huge impact on me. I was excited about being like them. I didn't know if I could do what they did, but I thought science is really important. We have to get it right. If you find out the right things and people don't like it, it's going to be dangerous. But that just proves how important it is. So when you worry about whether science is under attack, it's a point that I take is it just proves how important our work is. So let's go ahead and tell you more about where we came from. But if you're a serious scientist, you want to be able to explain this document. This is the Declaration of Independence from 1776, getting on towards, what, 240 years ago now? So a few things to point out about this. There's not a thing in here that you would take to be science. It doesn't say anything about protons, electrons, neutrons, atoms. None of that was known in 1776. But this document was written in part by Jefferson, who was the most scientifically interested president we ever had. He would have been a scientist. And some really important words in here came from the greatest scientist of that day, Ben Franklin. He wrote the words, "We hold these truths to be self-evident." So Jefferson was a president who really wanted to do science. When he got the opportunity to acquire the Louisiana Purchase, people said, that's unconstitutional, you can't do that. Somehow he managed to persuade people to do it anyway. So then we had this gigantic new territory to explore, and he sent out the first federally funded scientific project, the Lewis and Clark expedition, which was extremely dangerous, nearly fatal, went way over budget, took much too long, and they didn't publish all the results. But that was a time when the only way to get to the West Coast was to walk or take a canoe. So we learned a vast amount of information from that first scientific expedition, and we've been proceeding ever since. Something else, however, about this document, it talks about abstract things. It's the document that creates the idea of unalienable human rights. At the end, the founders talk about they pledged their lives, their fortunes, and their secret honor to make this happen. So that's abstract. It's not about the science. But when we understand how people are able to do that, then we've made some real progress. So I want to talk now about the easy part, the cosmology. So a lot of people have heard of the Big Bang Theory. They watched the TV show. And by the way, storytelling is important. The enrollment in physics undergraduate courses has doubled since that show started. So it's not so bad, right? So I want to point out here how it is that we measure the universe. First thing, we have time machines. Each of our eyes is a time machine. Each of our ears is actually a time machine because we see and hear things as they were when the signals were sent to us, not as they are now. So if you look out at the farthest galaxy you can see, it's the Andromeda Nebula. It's about 2 million light years out there. So you can see, you're already seeing 2 million years back in time just by doing that. So now we can look back in time, but how far are you looking? So we now have to survey the universe. So we've been doing this for a long time. The ancient Greeks were able to do the first step. They were able to not do it with stars, but with the moon. They were able to estimate the distance to the moon because they knew they were moving their heads around as the Earth would rotate. And they had already measured the size of the Earth, so they got the distance to the moon about right. They did not get the right distance to the stars because the angles are too hard for them to measure. So anyway, triangles, trigonometry will measure the distance to things if you can move your head. If you can't do that and the technique doesn't work anymore, then you measure what we call standard candles. If I promise you that those two candles that I've drawn there are identical, and one of them looks fainter than the other, you say, well, it's probably because the faint one is farther away. So we can now calculate the distance to everything in the universe by the combination of these two techniques. Now, it's not so easy, so it's taken and we've made a lot of mistakes. But anyway, we've pretty much got it now. So now we want to know, how do things move? So mostly things don't move very fast across the sky. The only one you can really sort of notice yourself is that the moon, while you're watching in the evening, will actually move relative to the stars behind it. If you sit there for an hour, you can tell. But the other things, they don't move enough. So our